All right, let's go and talk about exponents. All right, very first thing I want to show you is if I have the number 5 and I have a small 2 above it, actually written as a superscript, we call 5 the base. It's the one that's on the base. It's written bigger. And the exponent itself is the one that's up high, written smaller. Okay, it's pretty obvious, but it's just a part of the lesson so that you understand what we're doing. Now, I can show you why exponents are kind of important. They help us to understand it. We use a lot of it, especially in advanced math and so forth. This here, I just kind of drew this really sloppily, but if I have a room, well, it's a small room, and it's 4 feet by 4 feet, all right, I could write it as 4 by 4. When the base is the same, I can use the exponent to show how many times there is the base, right? So that means I've got 4 squared. 4 is the base, it's 2 times. So if I have 4 here by 4 here, I just square it, and the exponent tells me how many times to multiply the base. I take the 4 and I multiply it by itself, how many times? 2. So what's 4 times 4?
16.
16, all right? It's funny that you say that because if you do 16, we don't want that, okay? So just remember that. It's always, always, always multiplication. If we had a room that was 10 by 10, all right, 10 foot by 10 foot, it's a little bit of a smaller bedroom in a home, but it would be 10 by 10. Let's say, excuse me, that you tiled it instead of had carpet, all right? And they were 1 foot squares. In fact, all along the school hallway, all of those tiles that you walk on are all 1 foot by 1 foot. They're 12 inches, okay? Well, if you multiply 10 times 10 or 10 squared, what do you get? How many tiles would you need for your bedroom? 100, right? And that's exactly what exponents can be used for. Obviously, it works for a square. Your book shows 5 times 5. How many of you have seen a Rubik's Cube before? Okay? You've seen a Rubik's Cube. A Rubik's Cube, the face of a Rubik's Cube has how many squares? It has 9, doesn't it? And how many pieces by how many pieces? All right, has 3 actually, doesn't it? Looks kind of like this. All right, drawing it real quick. Okay? Well, 3 in height, 3 in the depth, all right, 3 in the length. So 3 times 3 times 3. It's written as 3 to the third. But it's not the answer of 9, right? It's not 3 plus 3 plus 3. It's, what's 3 times 3? 9. 9 times 3 is? How many pieces are in a Rubik's Cube? 27 pieces. One row has 9, and there are 3 rows, okay? So it helps us to explain some exponents. And what we're going to do is kind of show you a little bit what the examples here from our book as we flip the page and we see. The first one is this here, all right? How many 2's are there?
4.
So we could rewrite this as 2 is our base, all right? And there's how many? 4 2's. And if we were to solve it, it's 2 times 2 times 2 times 2, which is?
16.
4 times 4, good, 16, all right? This one here, how many do we have? We have actually 3 as -3 being our base, right? And we have 3 of them, okay? So that means expanded, -3, -3, -3. I'm going to write this in parentheses. We're going to learn that in a minute. So a -3 times a -3 is a what? What's a negative times a negative?
Positive.
Positive 9, but a positive 9 times a -3 is a -27. Remember we talked about with multiplication and factors, if there's an uneven number of negatives, our answer is negative. Okay? If there's an even number of negatives, then our answer is positive. Okay? So that kind of helps us to know and understand. All right? Now, as we go through our book, I just want to go through what we're doing here. It looks like, okay, 9 to the third. All right? Our next one is, where are we at? 100. Thank you. All right. I wrote them out of order. 9 to the third. Okay? The base is what, class? 9. The exponent is?
3.
The exponent tells you how many times to stamp the base, okay? So 9 stamped 3 times. 9 times 9 is 81. 81 times 9 is what? 729. 729. So 729 is our answer, okay? Easy enough? Easy enough, okay? If I had a 5 there, I'd do 5 9s. If I had a 2 there, I would do 2 9s, 9 times 9. If I had nothing there, there's an imaginary 1 all the time, but we never write it, okay? You're 14 years old to the first power. You're just 14, okay, or 13. 9 to the first, okay? The next one here, look at this one. This is in parentheses. So the 4, now watch this, this is good stuff here. The 4 tells me how many times to stamp what? -7. But I don't just stamp -7, I also stamp the what on the outside? The parentheses. It looks like this. Okay? How many negatives are there?
4.
4. Okay? Even. So we know the answer is positive. Then we take 7 times 7, which is 49. 49 times 49 if you want. And what's our book say, class? All right? I think our book has it in there. Where are we at? 2,401, and it's positive, okay? Letter C, take a look at this. This is part of our thing. -4 squared. Okay, now watch this. This is different than this. Because this doesn't have what? Parentheses. So you know what this means? This is, watch how I say it, -7 to the 4th. This is -4 squared. Notice where the pause was at? Okay? So if I don't have parentheses, this is actually the opposite of 4 squared. Almost written a little bit like this, separated. Okay? So I solve the outside always first. 4 times 4 is 16, and then I add my negative. So there's the answer. Okay? We'll run into more of those, and hopefully that'll be kind of a help to you, and you'll notice what happens. Now, what we're going to do is show you 3 things. This is fast. You got to replay the video to see it. You can, but this is the rule. This is how it is. Okay? There's no exception. You ready? All right? X to the A times x to the b is equal to x to the a plus b. Okay? Wah, 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 wah. What does all that mean? We'll get to it in a minute, trust me. Okay? That means when we multiply exponents with the same base, we add, all right? X to the a divided by x to the b is to the a minus c. So here we're multiplying and we add exponents. Here we're dividing, that means we subtract exponents. It works beautifully, it's the opposite. Here is x to the a raised to the b power means x to the a times b. We just multiply these two, okay? Wow, what's that mean, Mr. Bays? Well, let's do it. You ready? 5 squared times 5 to the 10th. Are the bases the same, yes or no?
Yes.
They are. So when the bases are the same, we take the 2 exponents and what do we do when we're multiplying? Yeah, what's 2 plus 10? 12. It equals 5 to the 12. Now, we're not going to multiply that out, and your book doesn't want you to. Okay? Let me tell you what it's not. Okay? It's not 25. We don't multiply 5 times 5. That's the base. The base of the x's stays the same. You got it? It's the exponents that we add when we multiply. Okay? So 5 squared plus 5 to the 10th equals 5 to the 12th. Not 5 to the 20th. Don't you do that. Okay? I don't want to hear it. I don't want to see it. You got it? We're not doing that. We're not even going there. You're not going to write that at all on your paper and make a mistake. Because when we multiply exponents, we do not multiply their exponents. Or when we multiply, we don't multiply their exponents. We add them. If this was a 10, we would have 5 to the 20th, right? Got it? Hey, watch this. What if that was a -2? -2 and a 10. Different sign or the same?
Different.
Subtract, keep the sign of the larger. What's 10 minus 2?
8.
Yeah, 8, but that would be a negative, so it would be a positive, so it would be 5 to the 8th. That's crazy stuff. We just learned that. I told you we're going to have to know that sticky note, right? Okay, here we go. We got 3 of them. Are all the bases the same?
Yes.
Yes. When we multiply, what do we do to the numbers?
Add.
Exponents, we add them. What's 2 plus 4?
6.
It's right around 6. 6 plus 9 is right around 15, all right? 3 to the 15th. That's what that equals. Okay? What number is that right there?
1.
It's a 1, it's an automatic 1, right? We already know that. But this is a what problem? Division. It looks like this. 2 to the 4th divided by 2 to the 1st. So when we multiply, we add exponents. But when we divide, we subtract. 4 minus 1.
3.
3, all right? Equals 2 to the 3rd. Love it, I love it, awesome. 10 to the 5th. 10 to the 5th divided by 10 to the 3rd. Okay, subtract. Is 10 to the what?
10 to the 2nd.
10 squared. We do not divide the 10 and make it 1. That's not what we're doing. It's the bases that stay, okay? Last one here, I think I had an example. Yep, well there's one over here. I'll just kind of cheat and do that, okay? 5 to the negative 3rd to the 4th. So A times B. What's negative 3 times 4?
Negative 12.
Negative 12. 5 to the negative 12 is the answer. All you gotta do is multiply the two outside exponents. Is that crazy or what? Okay? All right, let's keep going here, all right? Let's see here. Our book, negative 2 to the negative 4th, all right? In fact, let me just make sure I'm on with our, let's see here, okay? All right, now, here's what we gotta do. We gotta understand that when we have a negative exponent, I want you to remember two words, 1 over, okay, 1 over. So you need to remember that. This is the same as 1 over negative 2 to the 4th, okay? So if I have 3 to the negative 2, anytime my exponent is negative, I remember the words 1 over, okay? So 3, anytime I have a negative exponent, I'm going to write, negative exponent, 1 over, and then I rewrite it with a positive exponent. 3 squared. What is 3 squared? 9. You're doing it already. Don't write 6. 1 over 9 is the answer, okay? So that means 2 to the negative 4th, 1 over negative 2 to the 4th. It's not the big base that's changed. It's the exponent that changes to a positive. All right? So 1 over negative 2 stamped 4 times. Okay? How many negatives are there?
4.
4. So that means it's a
Positive.
positive. And 2 to the 4th is 16. So the answer is 1 over 16. Don't put 16. Okay? All right, good. Now here's a couple other examples. We're getting there. Negative 3 to the negative 2. Oh, ding, 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 ding. Negative exponent. What do I write? 1 over. Ding, ding, ding. Equals 1 over. Then I rewrite the whole thing with a what? Not negative exponent, but a positive exponent. Negative 3 squared. Okay? Do I see a negative sign? Do I see parentheses?
No.
No, I do not. So that means it really looks like this. 1 over negative 3 squared. See how I separated that? What is 3 squared? And don't say 6 either. 9. Thank you very much. Our answer is a negative 1/9. These are principles to live by, all right, in math. Good stuff. All right, giving you a lot of rules today. We're going to put them in place. It's just awesome. It really, really is, okay? Now, look at this one here. Kind of tricky, but we can do it. 1 over 6 to the negative 3rd. Wait a minute. Negative exponent. Ding, 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 ding. All right, what do we have? 1 over. Let's actually just do this right here, okay? So we write 1 over 6 to the 3rd, and we made it positive. All right? 6, excuse me. 6 times 6 times 6. All right? So 6 times 6 is 36 times 6. All right? 6 times 6 is 36, 18, 19, 21, 216. All right? 1 over 216. Right? Got it? Everybody understand that? Now I'm going to put that back in the denominator. All right? I'm going to put it back in there. So 1 over 216. All right? Now, we always flip the what fraction when we divide? The second one. So 1 over 216 becomes 216 over 1, right? So that means that's 1 times 216 over 1. Answer is 216, okay? What a deal, all right? Now, that helps us to understand what's going on. Now, there's a lot of rules here, but you know what? The reality is once you start practicing your homework, you start seeing them again, we work them out. It's a blessing, it really is. And you guys get them straight, get them in your mind, and understand especially these 3 things, and then the 1 over as well. I know there's kind of a lot there, and you'll get some good practice in, and that'll kind of help. All right, take a look at this. All right, when we multiply the same bases, what do we do again? We add. All right? What's a negative 9 and 7? Different sign, we subtract. Keep the sign of the larger number, which is 9. So 3 to the negative 2. All right? But we don't leave at 3 to the negative 2. That's really bad. All right? Ding, 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 ding. All right? Negative means 1 over. So we write it as 1 over 3 squared. And our answer becomes 1 over what? Not 6. 9. 1, 9. Okay? How about this? Negative 3 plus a negative 2. Same sign. Hey, watch. Same sign. We add. Keep the sign. What's 3 plus 2? 5. Okay, 5. Negative 5. 2 to the negative 5. Look, 2 to the negative 5. Ding, 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 ding. All right? Negative exponent, 1 over. What's 1 over 2 to the 5th? Anybody know? 1 over 2. What's 5 2s? 4 2s is 16. 1 more 2 would be? 32. 32. Thank you, ma'am. All right? 1 over 32. Okay? Got it? Division. Oh, look at this one. Watch that. I'm going to put that one over here when we got some room. Somewhere. Okay. 4 to the negative 2. You ready? 4 to the negative 2 divided by 4 to the negative 3. Okay? You ready? All right? Now, when we divide, we can do this one of 2 ways. When we divide, what do we do to the exponent? Subtract. Same base equals 4 to the, watch this, negative 2. And when you do this with negatives, here's what I like to do. I like the division bar to always kind of act like our middle subtraction. You have to remember the subtraction here. Negative 2 minus, whoops, minus negative 3. Okay? This problem is not this. Negative 2 minus 3. Okay? That is incorrect. You always have to have a, you see the minus? There's the minus right there. But look what B is. B is a negative 3. So it's a minus negative 3. Because a minus is a plus. So 4, here's plus. Oh, different sign. Subtract. 3 minus 2? 1, okay? And it's positive, so it's 4 to the first, which is 4. But if you do it wrong, this is a negative 5. And it's not 4 to the negative 5th, it's 4. Okay? You'll run into more of those. It's like, oh, Mr. Ray, goodness. Yeah, you can do it. Put your mind to it, okay? A lot of stuff there. We will work through it certainly together. So just remember your rules, okay?